Try 4 problems on your own and press pause until you have your answer. So the first problem, the answer is where they cross. They have one solution, and that point is the point 1, 1. This next one would be no solution because they're parallel lines and are never going to cross. The next picture looks a lot like it has just one line, which means that it's infinitely many solutions. And this last example has one solution where the two lines cross at the point 3, -1. If you aren't given a graph, then you can graph the two lines and see where they cross. So for the first line, I'm going to do that in blue. Begin with B, so begin with -2, and move with M, up 3, right 1. And especially when we're solving by graphing, we want to extend that and keep going so that it's easier to see where these cross. And bear with me while I try to draw this on a tablet. There we go, that's pretty good. I'll do the second line in red. So I don't see a B, which means that we're going to begin at 0 and rise up 1, right 1. If you notice, I already see where these ones are going to cross, so I don't really need to draw a whole lot more. What point do they cross? They cross at the point 1, 1 again. And then we just repeat the process over here. So begin with B, which is 3, move with M, which is 2, so up 2, right 1. Once again, keep going in both directions just so it's easier to see where these lines are going to intersect. And then the line x plus 5, so begin at 5, and then we're going up 1, right 1. Ding, 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 there's where we're crossing. And so let's count that carefully. That's the point 2, and then we go up 1, 2, 3, 4, 5, 6, 7. So the point 2, 7. The last thing we want to talk about is algebraically, what does it mean for something to be a solution? For something to be a solution, it means that when I plug in the x and the y, it's going to work in both equations. So these each have 3 answer choices, and what we need to do is plug in each of these points and see which one gives us a true statement. So if I try to plug in this first point, I would say my y is 5 equals 2 times -2 minus 3. Well, -2 times 2 is -4. Minus 3 is definitely not going to give me 5, so I can cross that one off my list. And I'll try the next one. So I'm going to plug in 1 for y. I'm doing this in the first equation first. So 1 equals 2 times 2 minus 3. 2 times 2 is 4. Minus 3 does give me 1. So I know it works in the first equation, so let's try it in the second equation. 1 equals the opposite of 2 plus 3. That equals 1, so this is my solution because the point 2, 1 satisfies both equations at the same time. If you've got the hang of this, then pause and go forward and try the other 3 examples on your own. So the next one, we're going to plug in 0 for y. So 0 equals 3 times -1 plus 3. That's a horrible plus, sorry about that. 3 times -1 is -3, plus 3 does give me 0. So now I'm going to try that in the second equation. 0 equals the opposite of -1 plus 3. Let me erase that and write that a little bit clearer. But you might have already noticed this is definitely not going to be true. 0 does not equal the opposite of -1 plus 3. So I know it's not that equation. Let's try the next one. So does -3 equal 3 times 6 plus 3? Well, 3 times 6 is 18, plus 3, I don't even need to do that. I definitely know that's not going to give me a -3. And so hopefully it's this last one. So 3 equals 3 times 0 plus 3. Okay, 3 times 0 is 0, plus 3 is 3, so that one works. And then 3 equals the opposite of 0, which is just 0, plus 3 is also true. Look at this point. If my x is 0, that means it's my y-intercept. And if I look at my equation, both of them have the same y-intercept. So I could have thought a little carefully about that problem and gotten down to that answer. Looking at the last two, we can kind of think a little bit strategically about this. The first equation is y equals 2, which means my y value is 2. So which of these points could we get rid of? We could go ahead and get rid of b because it does not have a y value of 2. So now I'm only left with a couple of questions. So now I'm going to plug in this point into my second equation. 2 equals negative 4 times 7 minus 6. Negative 4 times 7 would be negative 28. Minus 6 is not going to be anywhere near positive 2. So it's not A, hopefully it's C. 2 equals negative 4 times negative 2 minus 6. So does 2 equal positive 8 minus 6? Yep, 8 minus 6 is 2. So my point is negative 2, too. I could keep going in this same way with this last problem, but I want to look at the second equation. What's being done between the x and the y in this equation? They're being added. So what this is saying is that when I add the x-coordinate and I add that to the y-coordinate, I should get out negative 5. So let's look at each of these points. X plus y, what does that equal? 1 plus 6, that equals 7. So that doesn't work. Is negative 3 plus negative 2 equal to negative 5? Yes, so that one's a possibility. And then look at the last one. Negative 3 plus 2 would be negative 1, so it's not C. And we're just going to double check B in the first equation. So I'm going to plug that in right here. So negative 2 equals 2 times negative 3 plus 4. Negative 2 equals negative 6 plus 4. And is negative 6 plus 4 negative 2? Yes, so we were correct that B is going to be my answer. Great job.